Welcome to The Explainer. Today, we're diving into a really radical new way of training artificial intelligence, one that completely challenges that old idea that bigger is always better. This is a story about teamwork and how sharing might just be the secret ingredient to building smarter AI.
So this is the question at the very heart of AI development right now. For a long time, it felt like the answer was, well, yeah. Building these incredibly powerful AI models needed resources that only a handful of tech giants could ever dream of affording. But what if that's all about to change? To really get it, we first need to look at the problem with the old way of doing things.
You see, for the longest time, training a powerful AI was a game of massive scale. I'm talking about huge, centralized data centers that cost a fortune to build and run. This basically created what you could call a training wall, a giant financial and technical barrier that locked out smaller companies, independent researchers, and hobbyists. So on one side, you have these centralized giants. They're incredibly powerful, for sure, but they're also super expensive and fragile. Everything has to be perfectly synchronized, which is a nightmare. But what if there was another way, a totally different approach, a decentralized swarm, where lots of different computers could all work together, flexibly, to achieve something amazing?
And that new approach has a name. It's a method developed by the team at Jensen AI, and it's called SAPO. Now I know, it's a bit of a mouthful. It stands for Swarm Sampling Policy Optimization. But trust me, the idea behind it is beautifully simple.
Think about it like a study group for a huge exam. Each student does their own homework, right? They solve their own practice problems, but then they all get together and share their notes, their solutions, and the little tricks they figured out. What happens? Everyone gets smarter, way faster. That's the core idea of SAPO. The process itself is it's elegant. First, each AI model in the network tackles its own set of problems. It generates potential answers, which the researchers call rollouts. Then, and this is key, it shares its work with the entire swarm. The real magic happens next. Each model then gets to look at all the shared work from its peers and cherry-pick the most successful or interesting examples to learn from. Then it updates itself, and the cycle begins again.
So the secret sauce here is this idea of the aha moment, that flash of insight. If one single AI in this whole network has a breakthrough and figures out a brilliant new way to solve a problem, that solution doesn't stay locked away. Nope, it's immediately shared, and that single clever idea can instantly boost the performance of the entire group. It's literally collective intelligence in action. Okay, the theory sounds fantastic, right? Sharing is caring, everyone gets smarter together, but does it actually work in practice? Because theory is one thing, but results are what really matter. So let's head to the lab and see exactly how the researchers at Jensen put this whole idea to the test.
So here's what they did. They set up a really neat, controlled experiment with a small swarm of 8 identical AI models. And they threw some seriously tough problems at them, everything from algebra to abstract logic puzzles. But here was the most important rule. No matter how much they shared with each other, each model saw the exact same total amount of training data. That way, it was a totally fair fight.
Now this is where it gets really fascinating. They didn't just test sharing versus not sharing. They tweaked the recipe. As you can see here, they tried 4 different strategies. A baseline, where each AI was totally on its own, like an island. Then they tried a little bit of sharing, a perfectly balanced 50-50 split, and finally a setup where the AIs mostly learn from each other's work. So the stage is set. The big question is, did all this teamwork actually make the AI models smarter? Did those aha moments really spread and make a difference?
The answer wasn't just yes. The results were, frankly, dramatic.
Get this, a 94% improvement. Let that sink in for a second. The swarm that used that balanced 50-50 sharing strategy was nearly twice as effective as the models that were forced to work completely alone. And this chart just lays it all out, crystal clear. That bar on the left, that's the reward the models got when they were working in total isolation. Now look at the bar on the right. That's the balanced sharing group. The difference is just, wow, it's not even a close call. Teamwork, it turns out, pays off big time, even for AI. But hold on, the story isn't over. And there's a really crucial twist here. Because it turns out you absolutely can't have too much of a good thing. More sharing wasn't always better. The researchers discovered what they called a Goldilocks problem. Too little sharing and you miss out on all that collective wisdom. But, and this is the kicker, too much sharing and the whole system became unstable. The models would learn things really quickly, but then they'd forget them almost immediately.
That 4-4 split, that 50-50 balance, was the just right zone that led to stable, consistent improvement.
Okay, so this is way more than just a fascinating result from a lab. It has profound, real-world implications for who gets to build the future of AI. So let's zoom out from the controlled experiment and look at the bigger picture. To prove that this idea could work on a massive scale, the team did something amazing. They opened the system up to the public. Thousands of people from the community connected their own computers. I'm talking regular laptops, gaming PCs, you name it. And together, they formed one giant, diverse, and incredibly powerful learning swarm.
So why does this matter to you and me? The takeaway here is huge. This kind of approach could finally tear down those financial and technical walls we talked about earlier. It means you don't need to be a tech giant with $1 billion data center to contribute to cutting-edge AI. It democratizes the entire field, putting these powerful tools into the hands of a global community of developers, researchers, and creators. And that brings us to one final, really provocative thought. We've just seen pretty convincing proof that cooperation makes AI stronger, more efficient, and more accessible. So as we wrap this up, you're left to wonder, if AIs really do learn better together, what's the next big problem they could solve as a team? Curing diseases? Solving climate change? The possibilities are just staggering to think about.